In part 2 of this lesson, I'll show you how you can apply scalar and vector projections when calculating work in physics. We ended off with question 2, where we're asked a crate is hauled 8 meters up a ramp under a constant force of 200 newtons applied at an angle of 25 degrees to the ramp. Find the work done. Now below I've shown you the formulas that you need, but before we can apply these formulas, let's understand where it comes from. In the past, we've defined work as simply the force times the distance, but that only applies when the force is directed along the line of motion of that object. Look at the picture that we have. The force is being exerted at 25 degrees, and it's not in the motion in which the object is moving. Perhaps because the wire is situated at the bottom of the object and it can't be pushed in the exact direction. So in a situation like this, what we do is we find the component of the force along the horizontal. In our case, that's the horizontal. And the x component here can be found by taking cosine of 25 degrees times the hypotenuse of the vector, which is 200. I'll show you that. Cosine at 25 degrees is equal to the adjacent over the hypotenuse, which is 200 newtons. Rearranging for a, we end up with 200 times cosine 25 degrees. So we take this factor and we multiply it by the distance in which the object is moving, which in our case is 8 meters. So we'll multiply that by 8 meters. Now if we put this all together, that's the same thing as taking the dot product of the force F times the vector for the displacement. And if we break this down even further, that's the magnitude of F times the magnitude of D times cosine theta. So the magnitude of F here represents 200, cosine theta is this part, and 8 represents the magnitude of the displacement, which in our case is 8. As a result, this question is quite simple to do. You multiply all these out and you should end up with your work in newtons. Let's go ahead and do that. Make sure that your calculator's in degrees. 200 times 25 degrees times 8 gives us 1,450. And without regarding significant figures, we'll just report that the way it is. 1450. And this is in newtons. Let's move on to question 3. A force is given by a vector, and the vector is F with the x, y, and z components shown here, and moves the particle from a point P, which is at 2, 1, and 0, to another point at 4, 6, and 2. Find the work done. So we want to find the difference between these two numbers. That will give us the distance, and we can do that by subtracting each of these. So 4 minus 2, I'll call the displacement vector D. That's equal to 2, 6 minus 1 is 5, and 2 minus 0 is 2. So the vector connecting this point and that point is shown right here. Now, as before, we defined work to be the dot product of the force times the distance. We already know the vector for the force. It's right here. So what we will do is say that work is equal to F times D. We have 3 times 2, 6, plus 4 times 5, that's 20. 5 times 2 is 10. Adding all this up, we end up with 36. And if the unit of length is in meters and the magnitude of the force is measured in newtons, we can say that the work done here is 36 joules. Of course, if you make those assumptions. And there you have it. That is how to apply the scalar and vector projection of vectors in 3D.